This series of video clips deals with the topic of the particular times we are living in. The series initially starts with an astronomical explanation, and then arrives, with the last clips, to a spiritual point of view. The entire series of clips has as its theme the causes of the material and spiritual changes of our planet. To understand what is happening to our Earth, we must start from far away, and more precisely from the supernovae of our galaxy. This is the chart of all the supernovae that has exploded in our galaxy from year 100 AD to the present day. There were 7 supernova bright, color yellow, and in addition there are also 4 remnant, color blue, that indicate other explosions, but that were not seen. There is also a supernova outside the Milky Way, color red. All in the galaxy are 11. So we can conclude that in our galaxy, over the 2000 years period, there were 7 supernova very bright, and a possibly even triple number of supernova not seen because of the lack of telescopes. Based on the chart, we can understand that it has been a long time, 400 years, that a bright supernova has not exploded. So there is a high probability that one could explode in our galaxy, the Milky Way, very soon. Now let's go to a chart about our solar system. These are the sunspot from around the year 1600 to today. The minimal correspond to the cold period on Earth. Note the 2 known minimal, Maunder's minimum and Dalton's minimum. Maunder's minimum corresponds to a period during which you could skate on the River Thames in London. This for about 30 years. We see that solar irradiance is directly proportional to the period of each solar cycle. Much longer the period is, the less solar irradiation we will be. The chart at the top left corner indicates that, in the minimum solar periods, the solar cycle length also increases. The average solar cycle is 11 years, and we see that during the Maunder minimum it has increased to a maximum of 22 years. Now let's try to combine the 2 charts. The supernovae chart, and the one of the sunspots. We see from the graph, how the solar minimum periods fit with supernovae explosions. In the sense that, after the supernova explosion, on Earth there are periods of a solar minimum with consequent cooling of the Earth. The last solar minimum period seems to be caused by a supernova 168,000 light-years away. Calculations have been made, and it seems that a supernova can influence even from those great distances. We also note that the closer the supernovae are, the longer the period of minimum solar cycles. Let's try to make comparisons even with volcanoes. All the dates of volcanic explosions fit with supernovae explosions. Look at the gap between the supernova and the volcano explosion, and then the changes of temperature on the sun and the Earth. The volcano produces ash that is dispersed in the atmosphere and blocks the sun's rays, and as a result, the Earth cools down, but it also cools because the cosmic radiation of supernova also acts on the sun by decreasing its activity. It should be noted that most of the volcanic explosions occurred during the minimum solar periods. Cosmic rays during the solar minimum can reach the Earth more forcefully. The triggering of the volcano occurs almost immediately upon the arrival of cosmic rays. Let's see the earthquake relationship now. The red curves in the graph show us how earthquakes have always followed supernova explosions in time. Compared to volcanoes, there is a much greater time delay caused by the arrival of slower cosmic rays. At this point we have evidence of how a supernova causes drastic changes in the solar system. Both the Sun, with its cycle, and the Earth and all the planets suffer the consequences. The only data that does not match is that of the large earthquakes in Chile in 1960 and 1964. You will find much more details on the website. The dangerous limit of the distance of a supernova has been calculated by astronomers at about 20 light-years, and has recently been increased to 50 light-years. Through this other image, courtesy of ESA, European Space Agency, we can better understand the danger limit of a supernova. The photo shows the map of the galaxy, around the solar system, with a radius of 100 parsecs. A yellow circle indicates what are the limits of distance of danger for the Earth of a supernova, 20 to 50 light-years. Scientists say that the X-rays and gamma rays emitted by a supernova interact with the Earth's atmosphere and remove the ozone protection. At this point, all the lethal rays can enter and exterminate all living creatures, except those that live underwater. Based on the intensity of the rays, they have calculated a lethal distance of 20 to 50 light-years. Astronomers have not taken into account However, that the lethal radiation is not only that of X-rays, but also that of charged particles, cosmic rays, made up of electrons, protons, and atoms. These particles are fired by the supernova at speeds close to those of light, and cause large swings in the electric and magnetic field of the galaxy. How do they affect the solar system? A moving charged particle produces a magnetic field. This magnetic field is able to vary the solar and terrestrial field, causing the particles to affect sunspots, which decrease, and the Earth's core, which weakens. All the necessary calculations were done before publishing this video. We also see that the time difference between the supernova explosion and the corresponding explosion of volcanoes on Earth is about 10 years. This confirms the fact that the particles, which travel a little slower than the speed of light, arrive later. Let's now see how the danger distance limit of a supernova changes. Based on the evidence of the previous sliders, we can assume that the safety limit of the distance of a supernova is much greater than that calculated by scientists. In fact, if a supernova, such as SN 1572, which was at a distance of 5,000 to 8,000 light-years, caused many earthquakes and volcanic eruptions for 30 years, the decrease in temperatures throughout the northern hemisphere for about 30 years, then, assuming a distance of about 1,000 light-years, the incoming energy is about 64 times greater. This would mean hundreds of strong earthquakes and volcanoes for a period of 4 years. It is unlikely that civilization as we know it today could survive. The distance at which a supernova becomes dangerous to life on Earth increases from 20 to 50 light-years to 500 to 1,000 light-years. If a supernova were to explode within 1,000 light-years from Earth, it would cause hundreds of powerful volcanic eruptions and many large earthquakes. So it would be very disastrous for humans and for life on Earth. There are about 10 stars among the supernova candidates within a radius of 1,000 light-years from Earth, but no one knows when they will explode. Follow all the clips in the series without skipping any, to understand how to predict the explosion of a supernova. The entire series of videos, the evidence, has a very specific final purpose. To fully understand the latest clips, it is necessary to listen to the previous ones. In practice, it is a path that will lead the visitor to take note of future events and take the appropriate steps. So we invite you to follow clip number 2 of the series, the evidence, entitled, "The Local Cloud and the Journey of the Sun in the Galaxy."